Thank you very much for coming back to my channel. This is Hisakawa. This video is the development of the radio controllable Mini-4WD car Mini-4 out of scratch series volume 2. So let's get started. In the previous video, I designed and 3D printed a chassis for Mini-4 that employs a steering mechanism. The idea is to install two independent power transmission systems for the right and left hand side for the Mini-4. By controlling the rotation speed of the DC motors, the Mini-4 can turn right or left and even do a spinning turn. In this video, electronic mechanisms to control the Mini-4s are developed. The sketch of the electronic connections for the Mini-4 is shown. For central signal processing, a microcomputer is prepared. To control the DC motors, a motor driver board, the circuit, is used. It receives the PWM control signals from the microcomputer and changes the rotation speed of the DC motors. Infrared sensor provide a microcomputer with supplementary information, distance between the Mini-4 and the wall. It is useful for collision avoidance systems. All electronic parts are powered by AA-size batteries. At the beginning of the project, I planned to use two batteries, two 1.5 volts batteries that are directly connected to produce a 3 volt system. Later, I found that this is not enough to drive all parts. A microcomputer is key to this Mini-4 project. It generates control signals to change the rotation speed of the DC motors. It also receives control signals from an external device like a smartphone or a gaming controller. Anyway, I selected Speeed Studio Shell ESP32C3. It has a long name. This is the name of the microcomputer. Note that this is not a typo. It has 3 E's as speed. I don't know how to pronounce this word, but anyway, this is the name of the microcomputer. Okay, it has been developed based on the famous microcomputer named ESP32, and the tiny size of this microcomputer is better for Mini-4 size. Also, it can be connected to a Wi-Fi network or individual device via Bluetooth LE, low energy format. I soldered pin headers to the original board of the microcomputer. The soldering should be completed in a short time not to break the electric circuit of the microcomputer, like this. Okay, the DC motors are controlled by the microcomputer shell via a motor driver circuit. Connecting the motors to the microcomputer directly is not efficient because the power supplied by the microcomputer's electrode is usually not so high. Usually the rotation speed of DC motor is controlled by using PWM, pulse width modulation signals. And writing a program to generate PWM signal is not so difficult, but it is not efficient. Okay, so that's why I'd like to use a motor driver, and this is a motor driver circuit board. I also saw the pin headers for efficient connection to the circuit. The motor driver has two types of electrodes. Okay, they are electrodes that receive control signals from a microcomputer, and electrode to transmit control signal to DC motors, and also for power supplies, it is connected to the external batteries and ground, what we call 0 volt. Okay, when we use a motor driver board, we don't need to care about the power of the control signals. Control signals are automatically enhanced within the motor driver circuit, and the rotation speed of the motor can be controlled. Okay, the motor drivers enable us to control motors in a framework of a common, simple, and easy format. Okay, and soldering electrodes on the two tips was finished. Since two chips need to be inside a tiny Mini-4 body, the height of the electrodes was shortened. Okay, The video shows the preliminary experiment for motor control. As in the video, I prepared two lines of power circuit. One is for the microcomputer via USB-C from my computer. I mean my laptop. It is connected to my laptop. The other is for the motor driver using two AA-size batteries, but it is just a preliminary experiment, so please don't care about it. It's just an experiment. Okay. I also developed a program to change the rotation direction of the DC motor every given period. PWM signals are generated by the microcomputer and transmitted to the motor driver. As in the video, the rotation direction is successfully controlled like this. First, it rotates one direction, and in the second moment, the direction is changed like this. Okay, this is also a test experiment of the sensor. The infrared sensor successfully senses the distance between the sensor and my hand. I changed the circuit to detect the distance with not digital but analog signal. To develop the Mini-4WD as an independent system, every electronic part should be powered by AA-size batteries. As a result of some tests, I concluded that the directly connected two AA-size batteries still can cause a power shortage. The voltage is okay because it is increased by the DC-DC converter. It increases the voltage from one value to the another one. Okay. So the problem is that the capacity of the alkaline battery is not so high to power the microcomputer. Here to deal with this problem, I made an additional battery case to add the third battery. The additional case is placed at the rear of the Mini-4WD chassis like a rear car, and it is a removable one. The design of the circuit was changed like this. Okay. I think by introducing AA-size lithium-ion batteries, two batteries can generate power enough for the Mini-4WD. So I also placed the switch to change the circuit immediately. I mean, our circuit for two batteries and the circuits for three batteries can be easily switched by changing the position of the switch. Okay, let's move on to the assembling phase. 3D printed chassis, DC motors, sensors, microcomputer, a motor driver, and many other parts like cables or electrodes are assembled. Since a program to control the Mini-4WD can be easily changed, electrodes to connect each cable are not a big problem. However, electrodes that can receive the process analog signals are limited, and thus signals from sensors should be connected to such electrodes for analog signals. Okay. I think I should choose thinner cables. It's so tiny. I hope the additional battery case looks good. The next step is the LED illumination system development. I prepared additional battery space for powering LEDs to develop a more stable illumination system. 3 coin batteries are directly connected and the voltage is about 4.5 volts. I'm now cutting the tip of the LEDs to place them on the underside of the headlights, and a 222 ohm resistor is connected for circuit for current limitation because the LEDs are parallelly connected. Resistors are mounted on the electric board like this. Okay. And to fix the LEDs, I use UV light, ultraviolet light. It is fixed within 60 seconds to 90 seconds. I'm testing the work of the white LED on the right headlight. It looks good. The illumination testing version 2 is shown. The headlight was white and also red LEDs. Also, I placed 4 LEDs inside the front bumper. By the way, the electric circuit for the LED is separated from the main circuit, the circuit for microcomputer. All LEDs are turned on by a light switch. When the project started, I wanted to control the LEDs also by using the microcomputer. However, I didn't have enough number of transistors. The adopted circuit is much simpler but much more stable than the previous one, the control by the microcomputer. Okay, I'm finishing the video. All parts are connected to the microcomputer, directly or indirectly. In my opinion, the visual of the Minion is good. I hope you like it too. The next video is concluding this Minion series. I will develop a control software for the Minion to receive signals from external devices. The coloring phase is also shown. I tried various measures on coloring to create attractive body patterns and the colors of the body. Okay, this is the end of today's video. See you in the next video. Bye bye.